This question can look very challenging from a first glance, I think. So how on earth are we meant to know that whether these numbers are multiples of 7 when we don't even know what P and Q are? Well, all of them have kind of patterns, and it's trying to work out how do you actually get these patterns? What numbers must go into these numbers to get P, Q, P, Q, P, Q? And actually, the answer that you need to be aware of is that it's going to be um, it's going it's going to be a multiple of 1, 0, 1, 0, 1. Because if I take 1, 0, 1, 0, 1 and times it by, say, 23, all right, let's work out that. Then I'll do 23 times 1, and then I'll do 23 times 0. Then I'll do 23 times 1 again, but I've added two zeros because it's actually 23 times 100. And you can see it being generated now. Then the last one will be 23 times 10,000, essentially, and I'll have four zeros. So I'm going to get 232323. So that is essentially how we get PQ, 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 or QP, QP, QP. This one here must be 10,101 times PQ, whilst this one here is the same again, but times QP. Now, PQ and QP can be anything, and you can see that 7 doesn't go into 23. The question is, does it go into 10,101? Because if it does, this must always be a factor of B and C, and we can rule them out. They must be multiples of 7. So 7's into 10 go once, 7's into 31 go 4, remainder 3, then 4 again, 3. Yes, they do. So the answer is not going to be B and not going to be C. Um, it might be worth also thinking about what else goes into 1443, because this is quite a special number that you do see from time to time. You can try and find the prime factorization of it and just be aware of it from here on. I'm not going to talk about that here. I'll leave that as an exercise. Now, actually, D is also a special case. D is just a case where Q and P are the same thing. So I can also rule out D. That would simply be 10101 times PP. It's going to be a multiple of some other things as well, but actually it's going to be a multiple of 11. It would even be a multiple of 111, but anyway, we're okay because we ruled out from here. So now we're just left with A and E. So let me look at A to start with. How do we get PQQ, PQQ? Well, it's not going to be 10,101. It's going to be something else. But see how I did it here? It was like 1, 1, 1, and a 0 and a 0. I can kind of apply the same sort of thing. It's going to be 1, 0, 0, 1. Actually, A is going to be a multiple of 1001. Let me convince you. So let's do, again, let me choose 23. So 1001 times 23. We're going to get 23. And then we're going to get 0, 0, 0, 23. Actually, that's not quite going to work because I'm going to get 23023. So I think I need to do a three-digit number to make this work. So let's do 1, 2, 3. Sorry, not 1, 2, 3 though, because I want it to be repeated, don't I? So let's try 2, 3, 3. Okay, when I times it, I'm going to get 2, 3, 3, and I'm going to get 0, 0, 0, 2, 3, 3. So that fits in. P, Q, Q, P, Q, Q. Here, I'm getting 2, 3, 3, 2, 3, 3. So what I'm trying to get at is that it must be that 1001 goes into this number here. So let's see, does 7 go into 1001? Because if it doesn't, we could just pick a Q and a P such that 7 doesn't go into it, like 2, well 322. Actually, you'd have to look at it and think about it. but you could find one. But let's see if 7 goes into this. So 7 goes into 10 once, remainder 3. 7 goes into 34, remainder 2. Okay, again, it goes into it, which means that it also cannot be A, so it has to be E. That's the answer. Now, maybe you're not convinced by this. Maybe you think, well, maybe you've made a mistake. So let's have a look at PPPQQQ as the last one. Actually, I talked about this before. This one, it must be that 111 goes into this, because if you had, um, you can see 111 is going to go into the first three digits, and then it's going to go into the second three digits. And it's going to be something like 2000, 2002 times 111, because you get not 2002, 3002, make the digits different. So then we're going to get 222, and then 000, we multiply by the 3000, and then 333. So that will give 333222. Now we can definitely pick P and Q such that 7 won't go into like this number here. Okay, that will be possible. So the question remains, does 7 go into 111? 7 goes into 11 once, remainder 4, and then it goes into this one 5 times, remainder 6. So that is a reason why, it doesn't go into it. And actually, if you started here, you could have done this question very quickly, but obviously it's probably also the easiest one to realize that 111 goes into it. So it's not like it's, oh, how would I know to start here? I didn't start here because I didn't want to just get the answer straight away. I wanted to like talk you through all the other parts. When I actually did the question myself, I also didn't start there. So it's not like it's obvious to start with that one or anything. So I hope I've convinced you. It's like I'm trying to explain it, but it's obviously it's a lot. Once you know this fact, once you know how you generate these sorts of numbers that you need to times by 10,101 or 1001 or 111, this question is not so bad. It's like understanding to do that to start with, but I suppose that's the whole point in going over it. I hope you're happy. Okay, thanks for watching this.